Let's talk about Newton's second law. Now, Newton's second law is often written like this, where we have the net force is equal to the mass of an object times the acceleration. So this is saying that the net force on an object is equal to the product of the object's mass and its acceleration. And of course, acceleration is a vector. This is a vector equation, so of course we would write it like this. We'd say the x component of the net force equals the mass times the x component of the acceleration, and we would also do the same thing for the y component. So there you go, that's Newton's second law. But there's actually quite a bit more to it, and it all has to do with the net force. When we say the net force, what we really mean is the total of all the forces acting on the object. So when I say the net force, what I just said was it's the total or the sum. That's a terrible sum. Let's do that again. It's not much better. There we go. The sum of all the individual forces acting on the object. So what we really want to be doing with Newton's second law is identifying all the individual forces acting on the object and accounting for those in Newton's second law. So you can see over here on the right, I've got my object. This is my object, just a little green ball. And what I want to do is draw the forces that are acting on it. So we could have a force that's acting, say, to the left. Whoops, that's a mistake. It's acting to the left on it. And let's say we've got a force that's acting up. And we'll also have a third force that's acting at an angle. And then we need to label these. Now we'll be talking about all sorts of different forces, but for now I'm just going to give them generic labels. So this will just be F1, F2, and F3. And I want to show how these forces get put into Newton's second law. So let's start over with Newton's second law. Now I'm going to say that instead of writing it as the net force, I'm going to write it as the sum of all the individual forces has to equal the mass times the acceleration. And this means that I've got my three forces, so I've got to do F1 plus F2 plus F3. That has to equal the mass times the acceleration. And now I've got to write that in its components. So that means I've got to write it as F1x plus F2x plus F3x equals ma sub x. And we got to do it again for the y. F1y plus F2y plus F3y equals ma sub y. This is what is really, shall we say, somewhat different about Newton's second law, perhaps in comparison to other formulas you've seen. Other formulas, it's just stated, everything's just right there. But with Newton's second law, you actually have to build it. Specifically, it's the left side. You are building. You have to identify how many forces there are. And so it's important to draw the forces, as I did up here. This is called a force diagram, or sometimes people refer to it as a free body diagram. But you want to draw the forces, specifically the directions they're acting, and you need to account for all those forces on the left side of Newton's second law. And a lot of times what happens is that some of these components are zero. If we look specifically at in our case, you can see that F1 and F2, these are axis vectors. So F1 has no x component. So I could say, oh, the x component is 0. So in my case, this one is going to go to 0. So this just becomes f2x plus f3x equals max. So that's simplified. And for the y, we see f2 has no y component. So this is 0 in this particular case. So this becomes f1y plus f3y equals may. It's quite common for some of the components to be 0 with your forces. A lot of the forces will end up being axis vectors. So we're going to be taking advantage of that. Often the acceleration will also be an axis vector. And that means, of course, one of the components will be 0. Sometimes there won't be any acceleration, in which case both ax and ay are 0. So that's further simplification. But this is the idea. This is Newton's second law. You've got to draw your force diagram, and then you have to build the left side of Newton's second law. That's what we did here. We built it by adding together the vectors and immediately breaking it up into the x and y components. And that's Newton's second law.